Okay, so I'm going to share my notebook screen for you. Okay, so you should see that. So notice I've got some things drawn on here, and it looks very similar to what we did in Monday's class. So if you remember in Monday's class, I drew a function very similar to this, and I don't think I labeled that one in numbers, but I closed off an interval from A to B. But that interval was closed so you could see that it had brackets. And we talked about what it means to be an absolute max or an absolute min. And I found out that for all my closed intervals, as long as the interval was closed, I would have both an absolute max and an absolute min in every one of those intervals. Because if you think about it, if you restrict to a certain set of values and it begins at a place and it ends at a place, you're definitely going to have a highest point in that interval and a lowest point in that interval. And we talked about how to find those. But you guys, today we're going to be on open intervals, and it doesn't seem that different. I mean, it's just parentheses instead of brackets, but it really does change things. So let's look at this function I've got here. Notice that I have created an open interval from x equals 1 to x equals 7, and I've labeled those points on this graph. So I need to remember what those parentheses mean and why it's called an open interval. It means that while my interval goes from 1 to 7, 1 is the leftmost point and 7 is the rightmost point, it means that I can't include 1 or 7 in my interval. So it's more like, instead of saying I have an interval from 1 to 7, it's more like saying I have an interval between 1 and 7. Now, when I want to know about absolutes on an open interval, I'm not always going to have both a min and a max. And you might look at this and say, well, I can see a lowest point and a highest point, right? You want to, now the lowest point on this graph is actually not at an endpoint, it's at a critical point, which is fine. It means we do have a lowest point on this interval. But let's try to find a highest point. So I know that this critical point would end up being the absolute minimum on this interval. But let's try to find an absolute max. You might say, oh, well, it's just this point really close to 7. You can't say it's 7 because remember 7 is not in your interval, but maybe you're just like, oh, it's just this point really close to that. Well, how close is the question, guys? So this little green point that I picked, yeah, well, maybe x is 6.9 there. And then I get this y value, whatever that is, and that's my absolute max. Is it though? Because I think I can find a point that's a little bit higher, still within my interval, still less than 7. I say, oh, no, I'm going to get a little closer. And you know, you can't really draw that on a picture, but you could get closer. You could say, well, what about the point where x is 6.99? That's going to be a little bit higher y value, a little bit closer to 7, but still not touching 7. So look, I just found a value that's higher than that. So this one's not the max. Maybe this one is. And then somebody else is like, no, I'm pretty sure I can get higher within that interval. And they give me a point where x equals 6.999. And you guys, the y value would go up just, you know, a very minuscule amount, but it would go up because it's approaching that point where x equals 7. You guys, you could keep doing this. Just keep adding 9s, keep getting closer. The thing about an open interval is that it doesn't have a strict stopping point. If our interval went to 7 and it was closed, it would hit 7 and stop at 7. But on an open interval, you can approach the endpoint of 7, but you can never get there. So think about that approach like we talked about when we were doing limits. We can get infinitely close to 7 or to x equals 7. but we can't actually stop at 7. So infinitely close means infinitely close. You say 6 with 4 nines there, I put another 9 on there and I'm even closer. Guys, what it means, because I cannot include that endpoint, it means that I actually have no absolute max. And it's hard to think about that because on a picture, you can see, oh, well, there is a high point in there. It's just the one as close to 7 as you can get. But as close to 7 as you can get really isn't a thing we can define. So if your high or your low point are occurring at an open end, you can't actually call that a max or a min. So let me draw another section, or let's make another interval. Let's go from, let's say this is -2 to -6. I know this is super off scale. Don't worry about it. So let's say my interval was over here and it's open. So from -6 to -2, because we always write it left to right. Let's see, that point maybe is right there, and we're here. So on this interval, there is a high point. There is an absolute highest point in this interval because I can see it right here. It's the highest it goes, and then it goes back down. This, again, is occurring at a critical point, and this time, this is the max. But you guys, if I asked you for a minimum, that's going to be a problem because the lowest point in the interval is actually this open end. So again, I could say, oh, well, maybe it's, really close to that value right here, but you can always get closer. When you think you are as low as you can go without actually hitting x equals -6, you can go lower. You guys, you can get infinitely close. So on this one, because your interval is open, there's no absolute min. So notice in both of these intervals, the way the graph looked in both of these places determined if there was a max or a min, but there wasn't both. You guys, you're never going to have both in an open interval. Well, I guess you won't have both. Now, technically, let me show you why I'm taking that back for a minute. You guys, what if my interval went from like -6 all the way up to 7? It would have both in there, or, depending on where these points hit and how it compares to that end over there. If you had 2 critical points in there, they could be a max and a min. But so no, you could possibly have both. You're not really going to. Your intervals are going to be smaller. But notice in both intervals, the only extrema, so the only max or min that I found in each of the intervals was at a critical point. So the endpoints are off limits now. Remember when we had a closed interval, and just like a little review, we went from A to B. So we had a closed interval. We wanted to know about absolute max and min. We had to consider the endpoints as possibilities and also critical points. And we had to test them all. Those are the only choices you have, critical points or endpoints. But in an open interval where you can't consider your endpoints now, critical points are the only option. So on these open intervals, honestly, it's going to be a lot like what you've done before. You're just going to find critical points because those are our only choice. If there's a critical point in your interval, you can say, oh yeah, that's the max or min, depending on what that point is. And then that's it. Guys, open intervals are not very different from like what we did in 12.1 and 2. So let me give you an example. It's on this page. All right, so I've got a couple of examples here. Oh, I forgot to write the intervals. Hold on, let me get them. 0 to 4, 0 to, okay. All right, so on this example here, I've got the f of x equals 2x cubed minus 3x squared minus 12x plus 1. I want to find any absolute extrema. So extreme values is what, extrema, if you see the word, just max or min. If you see the word extremum, that's just the singular version. So don't let that word throw you off. It just means max or min. But I want to find any absolute extrema on the open interval from 0 to 4. So just like every other problem we have worked in chapter 12, our first step is going to be find the derivative. I know I can't find max or min without critical points, and I know I can't find critical points without the first derivative. So let's find that first derivative. It's going to be 6x squared minus 6x minus 12. I know where to go from here if I'm looking for critical points. I set it equal to 0. Now look at all these 6's and factors of 6. You guys, let's take a 6 out of everything before I do the rest of the factoring. Makes it a lot easier to factor, remember, if you can take a number out of everything. Oh, wait, that's not what I wanted on this line. So from here, well, yeah, it is. Oh, guys, I'm losing my mind. Okay, so I'm here. You guys, how is this one going to factor out? I need a -1 in the middle. So I think I'm going to do x plus 1, x minus 2. That should get me there. And then remember, set each thing equal to 0, each thing with an x in it. Again, remember, setting the 6 equal to 0 doesn't make sense. And I know I say that every time, but it's just something I see. Like on tests and stuff, it's an easy mistake to make. Like you say, oh, 6, and you set it equal to 0, and for some reason you get a critical point at 6 or something like that. And no, it doesn't make sense. But when you have test brain going, the more I can guard you against making silly mistakes, that's why I say them over and over. But anyway, so here we have x equals -1 and x equals +2 as our critical points. So before we get too ahead of ourselves and think, oh, this is just a 12.1 or 2 problem, remember our interval. Remember, I am restricted to an interval. So now I have my critical points. Which one of these falls in my open interval from 0 to 4? Well, -1 is not between 0 and 4. But this one is. Sorry. So you guys, what I found here is that I do have a critical point in my interval. I know this is going to be either an absolute max or min for my interval. The question is which one, and I'm going to have to know. So you guys, what's the easiest way to classify a critical point? Well, in 12.2, we figured out the easiest way and the fastest way to classify if a critical point is a max or min is to actually put it in the second derivative. I haven't found that yet, but it shouldn't be too hard, right? Go from the first derivative up here and take the second derivative. You could always do this at the beginning, so you just have it. It doesn't really matter when you do it. But I've taken the second derivative, so that was easy. I get I get the second derivative here equals 12x minus 6, going from that first one. All right, so how do I test my critical point? I put it into the second derivative and see what happens. So when I put a 2 in here, the second derivative at 2 is going to be 12 times 2 minus 6. So 24 minus 6 is 18. So you guys, I found that it's positive. Remember what it means for the second derivative to be positive. It means that your graph is concave up. So positive up. It looks like a bowl. Which means if it's concave up at the point where x equals 2, that has to be a minimum, right? So what did I find? I found that on the interval from 0 to 4, we have one extreme value. It is an absolute minimum. And it occurs at x equals 2. Now, I don't know the y value, but I can find it. You guys, what if I need the actual minimum value? You put x equals 2 into the original. Remember, that's the only way you can get a y value here. I never care about the y values on the derivative functions, only on the original. So my minimum occurs at x equals 2. To find the y value there, I would put x equals 2. I'd put 2 into all these places, and I would get out a y value. So see how that just seemed like a question from 12.2? I mean, the only difference was that this critical point over here at the -1, the only difference was I had to realize that was not in my interval, so I didn't have to classify it. I didn't have to use it at all. So open intervals, I mean, there's definitely pros and cons, guys. The con is that you're never going to have a max and a min. It'll only be one or the other. But the pro is that I get to work the problem basically like I've worked all the other problems, especially in 12.2. Notice that when I did test a value, it was in the second derivative, not the original. Remember, the only time I ever test anything in the original is on that closed interval. So really in 12.3, what we find is that closed intervals are a lot different. We have to do a lot of different methods. And then the open interval, it's basically the same as what we've been doing. Hold on, guys. Are we having video problems? Is it working okay?
It might be frozen.
Okay. Here, can you see my squiggly lines?
Yeah, you're good. Yeah, we see it.
Okay. Well, I just got an email from a student saying that they couldn't see or hear anything, but it was weird because she's not a student in this particular class. And I'm wondering, it freaked me out, but I'm wondering if she meant to send it to a different professor. Because as far as, I mean, everything looks fine on my part at least. So yeah, so you guys can see. Okay. Whew, that scared me for a minute, but it's not me, somebody else. Alrighty. So you guys, let's do another one. So on this one, I have the function written out here for you so I wouldn't forget it. The interval on this one, I want to find any absolute extrema on the interval from 0 to infinity. So definitely an open interval starting at 0 here. It's a large interval though. And it doesn't matter how big or how small your intervals are on these problems. We're just gonna keep them in mind when we're finding our critical points. So let's do that. So find the first derivative. So this time we're gonna have 3x squared minus 4x minus 4. That looks right. And then I need to set that equal to 0. So on this one, I can't factor out like a 3 from everything. I have to leave it all there. So the factoring might be a little bit harder for us. So let's be careful with it. Let's think about, you know, factors of our first term, maybe 2 and 2. One of these needs to be negative. How about this one? That should do it. You guys, remember, you can factor this however you want. But remember what I do. I do factors of the first here, factors of the second, or, you know, what I think would be the answer, and then I check them on the cross. So this would be negative, not 2. That would be a negative 6. That would be a positive 2. What do we get? We get the negative 4 I'm looking for. So factoring this becomes 3x plus 2 and x minus 2. All right, so let's set each of those terms equal to 0. So I get 3x equals negative 2. Let's divide and get x equals negative 2/3. And then over here, I have x minus 2 equals 0 and x equals positive 2. So these are your 2 critical points. Don't forget, before you start testing these, you know, and finding out if they're a max or a min, only test the ones in your interval. So you guys, our interval is from 0 to positive infinity. So you guys, this negative 2/3, we don't even have to consider it. And that's good because we hate using fractions anyway. But you guys, this is the only one I'm going to consider. So you found your critical point. It's in your interval. All you have to do now is test. Oh, look, it's a 2 again, just like before. Now, before you test, why don't we go ahead and find the second derivative? So it's going to be 6x minus 4 is what this is going to be. How do I test it? I just stick it in there for the x, and I get 6 times 2 minus 4. 12 minus 4 is 8. And again, this is positive, you guys. So concave up at this point where x equals 2 must mean it's a minimum. So again, well, that's kind of not exciting. I got the exact same answer on both. But remember, you know, not different methods, but it was a different problem. We did different work at least. Don't get comfortable and think your answers are all going to be absolute min at x equals 2. Remember, if it does ask for the value of the absolute minimum, you're going to go ahead and put 2 into the original function and get a y value. Okay. So you guys, like I said, with the open intervals, there's really, other than making sure your crit points are in your intervals, there's not really any difference between an open interval problem and a problem in 12.2. I don't say 12.1 because, I mean, it's similar to that, but remember in 12.2, that's where we learn to test in the second derivative, which is a lot easier. I would highly recommend it. Remember in 12.1, we did the number line. You know, we had to stick it all on a number line and we had to test in the first derivative. You guys, this is so much faster. So that would be my choice. That would be, you know, what I tell you to. I want to do, let's see. I think that's good on those. You guys, just hypothetically, let's go back to this first problem we did. Remember, your critical point happened at 2, but we also had one at -1. We didn't consider it because it wasn't in our interval. What if my interval, my open interval that it gave me in the problem was 3 to 7 or something like this? What would happen if you found both critical points and none of them were in your interval? What do you think your answer would be there? First of all, you wouldn't have to test any critical points because they're not in your interval. And you guys, if there's no critical points in your interval, there's just none. There's no absolute extrema. It doesn't happen that often, but because I don't know, you know, exactly which problems you're going to get, just FYI, if you do find your critical points, none of them are in here. There's just none. Remember, because your endpoints, you can't consider those anymore. So it's all about critical points. Okay, so what I want to do now, and This is kind of going to be a summary of this chapter. Because it's, or this section, sorry, it's one section, but there's two very different methods in it, right? And you have to remember which is which. Okay, so let's start with the closed interval. If you have a closed interval, my R's and V's look like exactly the same almost. I should work on that. Okay, so if you have a closed interval from A to B, you guys remember closed just means you see the brackets. That's how you know. And it's brackets on both sides too. So we have a closed interval from A to B, and I want to find any absolute extrema, which is the goal of 12.3. Remember your first step is take the first derivative and set it equal to 0 to find critical points. Let's say find critical points in the interval, because remember, that's all I'm concerned about. What do I do next, though? I don't test those critical points in a derivative, right? I test critical points that are in your interval, let's note. So I was trying to put the two words together. You test critical points that are in your interval and both endpoints. You always have to test both endpoints in the original function. You guys remember your goal on this closed interval is you're taking your two endpoints and any critical points. You're actually just comparing the y values at those points. So if I need y values, I put them in the original. So you guys, this is basic closed interval, and then open interval is would look like this. You have your interval with the parentheses. You guys, step 1 is the same. But honestly, step 1, other than the interval part, has been the same since we've been in chapter 12. You set f prime equal to 0 to find critical points in your interval again. And step 2, though, is where it's different. You do test those critical points, but only test the critical points. Remember, we never test endpoints in an open interval because they're not actually part of your interval. And where do we test them? In the second derivative, because we use the second derivative test. Now, again, if you are a lover of number lines and you really like to do that number line test that we did in 12.1, you can test them that way too if you want. I just don't assume that anybody likes that better because the second derivative test is a lot faster. But either way, you test them. You find out if they're a min or a max. Okay, so this is 12.3 in a nutshell. There's not a lot else I can do with the open intervals, like I said, because they're basically the same as what we've been doing this whole time. But I would like to talk about what I'm going to do on Friday. So Friday, I'll just leave this. On Friday, we are not moving on to another section. We are going to do applications of these first 3 sections. I'm going to show you how to read through the problem, decide which method you're using. You know, because sometimes, because it's just words, you have to decide, okay, is that on an interval? And if it is it open? Is it closed? What exactly are they looking for? You know, you have to be able to figure all that out. I'm not always going to say, you know, use the 12.2 method or, you know, use the closed interval. You know, you have to be able to figure that out. So my goal on Friday is I'm going to pick a set of applications. We're going to talk about how to decide what to use, and we're going to use those things. And then, so I'm going to open a quiz on Friday. but it won't be due till, I'm actually gonna open it on Friday night and probably leave it open through Monday. So you have a little, so it's not just Friday to Sunday. That seems tight. So I'll open it on Friday. You'll have till probably Monday night to do it. And, but it'll be exactly what we were doing in class on Friday, you know, and it's not going to be very many questions because sometimes these take time, you know, there's a lot of steps on each one. So basically, you just need to make sure you can read through a question and know what you need to find. And that's what we'll do together on Friday. And then you'll have that quiz open and yeah. And your homework, let's see, let's recap what homework you have. So you have 12.2 part 2 and 12.3, and that's it on your homework for this week. So you know, and honestly, get that done before you take your quiz. I mean, of course you don't have to. They're both going to be open in a similar window, but that's good practice for a quiz. And again, don't think I'm just going to put you through the ringer on the quiz or anything. It's just you'll have a few questions and you will answer them according to things that you did in these first 3 sections of chapter 12. So let's see. I don't really have anything else for you today, though, so I guess I'll just see you on Friday then. You guys, would you like me to open like the quiz earlier, even before we've gone over this stuff, just in case you already feel good about this stuff and you want to start it, you know, to give you more time? Or do you just want me to wait till after our class on Friday to open it? No, there's just one 12. Oh, go ahead.
I was just gonna answer since no one else. Either way, I mean.
Either way, okay.
Yeah.
Okay, well, yeah, so as long as you guys don't think that me opening it early means you have to take it, you know, I mean, you still have as much time as, you know, until the due date. But I probably will open it early. That way, if somebody wants to get it done, they can. And no, there's just one 12.3 assignment. So that's up and it's just all together. So when you're looking through those problems, just make sure you look at your brackets. There's some closed interval stuff and some open. Some are just pictures. And I will tell you that all the pictures I put on are closed interval. So you can include your endpoints. It just in case it's not clear to you in the picture. But yeah, so otherwise, guys, work on the homeworks. It'll help you get ready for this quiz. And like I said, especially after Friday, you'll be able to read through a problem and you'll know exactly what you need to do with it. You know, how to pick out keywords and stuff like that. And that'll help you a lot. So I will see you then.